Now let's understand what is an infinite geometric series. Actually, infinite geometric series is a series that does not have the last term, meaning it's a series that does not end. I'll level this example. This is a series, but specifically it's a geometric series. Because in a geometric, the constant ratio between the terms, meaning t2 divided by t1 is equals to t3 divided by t2, which is equals to t4 divided by t3, so on and so forth. Therefore, the ratio for this series is 2, because 4 divided by 2 is 2, or 8 divided by 4 is 2. And then again, for a geometric, moving from one term to another, multiply the constant ratio. Therefore, finding the next term, 8 times 2, which is 16. And then finding the next term, 16 times 2 is 32. And then finding the next term, 32 times 2, which is 64. But the more the terms the more our series is getting bigger and bigger, because moving from 2 to 4 increase, moving from 4 to 8 increase. So if we gotta try to find out the next term, we will create 128, and then if we gotta try to add another term, your series it will over a whole. So that series, because increase forever and ever, how the point reach. So that series is an infinite. So here something is an infinite, selo se we ga se felele, ga ena mo ile re felela gona. So that is an infinite. And then another thing, whenever a series is not a specific point mo ile re reach, because this series ga ena mo ile re fela gona, it keeps on growing forever and ever. Therefore, that series it diverge. This series it diverge because gaina a specific point or a specific value mo ile re reach. And then another thing, Muki, the conditions for the convergent geometric series. But the word convergent is the opposite, the divergent. And remember, a divergent a series a specific point. A series a number reach, because that series increase forever. Now, if a convergent is opposite a divergent, so this means for a convergent, a series it can reach a specific point. A series you reach a certain number or a specific number. But for that series to converge, it's only to remedy these conditions. Meaning the value of r it's only to be between -1 and 1. This means the value of r it's only to be faster 1, but it be greater than -1. And then the value of r is 0. So that series it will converge if you meet these conditions. Our level example here, a series it converge. This series it converge because we got to try to find out the constant ratio for this series, which is t2 divided by t1, 1 divided by 2 is half, or t3 divided by t2, which is half divided by 1. So the constant ratio for this series is half. And then half is between -1 and 1, because half is less than 1 but is greater than -1, and then half is not equals to 0. So this series it converge because it meets these conditions. But for this series, the value of r is 2, and then 2 is not between -1 and 1 because r for this one is greater than 1. 2 if it are 1, so this means 2 is not between -1 and 1. Therefore, because this series it doesn't meet these conditions, therefore this series it diverge, it doesn't converge. But this one it converge because it meets these conditions. And then another thing, finally a sum to infinity formula. So this formula add some terms approach the infinity, a sum to infinity. The word sum add. So add some terms approach the infinity, and then this reach a specific point, because this formula, the value of r it's between -1 and 1. If we this formula, we calculate the sum to infinity. This means we reach a certain point, and then when we reach that point, let's say if your answer is 2, so this means the maximum number that you can reach is 2. This means you can never pass that number. So that's the idea behind the sum to infinity geometric series. And then in conclusion, we find out the sum to infinity, the value of r is between -1 and 1, and then that r must not be equals to 0. And then another thing, we find out the ratio for a certain series, and then that ratio is not between -1 and 1. So this means that series it doesn't converge, but it diverge. And then the ratio, but a number is between -1 and 1, and then that series it converge. So that's all for this tutorial. Now let's go over some practice problems or those questions in your test or in your exam. This is our example number 1. Explain why the infinite series 10 plus 5 plus 2.5 plus 1.25 converges. So what feel a series? This is our term number 1, term number 2, term number 3, and term number 4. Question why the series converges. Question the series is converging or not. So this series is converging. So why this series is converging. But for a series to converge, it must meet some certain conditions. These are the conditions. The constant ratio r, it's between -1 and 1, and then it must not be equals to 0, meaning the value of r it's 1, but if it's a -1 and it's 0, so these are the conditions. This means Arnardo find out the value of r, and then after finding the value of r, if the value of r it can meet these conditions, so this means that will be the reason why this series is converging. So finding the value of r is equals to t2 divided by t1, or you can say t3 divided by t2. It's the same thing. 5 divided by 10 is half. So because o ka kgona bona gore r e meet these conditions, because half e ka fase ga 1 and then half e feta -1 and half ga e lekane le 0. So this means the reason is because the constant ratio ya half is between -1 and 1. So therefore the reason to answer this question, the infinite series converges because -1 is less than r and then r is less than 1 and r is not equal to 0. But because o tla bo bontshitse gore na le the constant ratio r which is half, so ge ka ngwala in this way is correct. But if o ka no ngwala this way fela without showing the value of r, so you'll be wrong, because when I know r is between -1 and 1 but ga o se wa bontse the r. So if o ka bontse r is equals to half and then in conclusion or the value of r is between -1 and 1 and then r is not equal to 0, so that will be the correct answer. So anyway, that's it for this problem. Example number 2. Given the geometric series, so this is our series. Questionnaire: calculate the sum to infinity. This question, I think it's very easy and straightforward. That's about a sum to infinity formula. Yeah, the geometric series. It's a divided by 1 minus r. So this means we're going to substitute the value of a and the value of r. So the value of a is term number 1, which is 3. And then r is equals to t2 divided by t1, or t3 divided by t2. So in this case, t2 divided by t1 is 1/3. So this is the value of r. And then substitute, and no, the value of a is 3 divided by 1 minus r is 1/3. So pressing the calculator, the answer is 9/2. So this is our sum to infinity. And that's it for this problem. This is our next example. The following sequence forms a convergent geometric sequence. So this is a convergent geometric. So this is very important. We'll start ignore this information. And then number fill our first 3 terms. Now let's go to number A. Determine the possible values of x. So this means I'll answer this question based on the fact that this is a convergent geometric. For a geometric, the value of r is between -1 and 1, and then r is not equal to 0. So to answer this question based on this fact, this is a convergent geometric sequence. Now to answer this question, we find the value of r. So finding the value of r, that's about r is equals to t2 divided by t1, or t3 divided by t2. So in this case, t2 is x squared and then t1 is 5x. Therefore x squared divided by 5x is x/5, because x and x do cancel, and then rashala x 1 the numerator, and then rashala 5. So this is the value of r. And then from here, -1 is less than x/5, which is less than 1. And then this is r, remember, this x/5. Therefore this means x/5 must not be equal to 0. And then from here, resolve the value of x. This is just a linear inequality. the way it's about the linear inequality from grade 10 and grade 11. So arto shumisha the same thing. Now solving the value of x, arto multiply the both sides ka 5 because this 5 it cancel. So this means probably negative 5 is less than x, and then x is less than 5 because negative 1 times 5 is negative 5, and then 5 and 1 times 5 is 5. So this is the answer for number B, for number A, I mean to say. And then the answer really find the value of x because question got the value of x. So this is the answer for number A. And now let's go to number B. If x is equals to 2, calculate the sum to infinity. Reservoir a sum to infinity at the geometric. It's a divided by 1 minus r. So this means substitute take the value of a and the value of r. And reservoir the value of a is term number 1, which is 5x. So this means t1 is equals to 5x. But what if x is equals to 2? So this means to substitute x. And then this means our term number 1 is equals to 10. So this is 10 divided by 1 minus. But let's find the value of r. So reservoir r is equals to x over 5. This is r. And then what x is equals to 2. So this means our r is equals to 2 divided by 5. So this is the value of r. And then from here, we'll substitute 2 over 5. So from this step, press the calculator. So now press the calculator, the answer is offer 50 divided by 3. And then 50 divided by 3, like another 16.67. So this is the answer for number B. And that's it for this problem. So you realize it's very important, or always don't ignore anything about Fayon. So this thing, it was the convergent geometry. So that is why I apply everything here. It's about based on the convergent geometric series. Level this example. Given that P is equals to, and then what if a sigma notation? What if a sigma notation? So this is a sigma. And then what if a counter from term number 1 to infinity. Remember this bottom part in either times until this number. So this means that either times from term number 1 to infinity. Either times based on this formula. This is our nth term formula. Remember this nth term formula, it can be either the geometric or either the arithmetic. Usually when you go to this formula, either the arithmetic or either the geometric. We'll find out your first 3 terms, and then those 3 terms they are direct or this is arithmetic or the geometric. And then another way, level the value of unknown always. In this case, the value of unknown is k. So if the value of unknown is in an exponential form, so this means deal with the geometric. But if it in a linear form, this means deal with the arithmetic. For example, let's say if n is equals to 1 or k is equals to 1, and then rather something like 2 plus 3n. Because this value of unknown n is in a linear form, meaning as an exponent. So this means this formula get the linear, the arithmetic. But if this formula is something like, let's say 2 to the power n, because it's in an exponential form, so this is a geometric. So in this case, because the value of unknown k exponent, so this means dealer le the geometric. So this means this sum ke the geometric. And then another thing that is very important, lemoga gore re add the terms tša rena from term number 1 to infinity re šomiša the geometric, because really this is a geometric. Actually this question one rela re go file a sum to infinity, because re add from term 1 to infinity of a geometric, because we're finding out that this is a geometric. And because this is a sum to infinity, yeah, geometric, already re a tseba gore a sum to infinity of a geometric is equals to a divided by 1 minus r. So this is something that we know about the sum to infinity of a geometric. Now let's go to number A. Determine the values of x for which p converges. If this is p and then if it converges, the only time a series is converge ke under this condition. So we find the value of x if this thing it converges. So we find the value of r, and then finding the value of r, this is our nth term. This means it will create our first term, our second term, even our third term. So at least our first 3 terms, we will create the value of r, because the value of r is t2 divided by t1. But in this case, our terms. But tn is equals to x minus 1 to the exponent k. This is our nth term. So we add the terms from term number 1 to infinity. So we can find our first term, x minus 1 to the exponent 1. We substitute 1 because we add from term number 1. So this means x minus 1 to the power 1 is just x minus 1. And then finding term number 2 is x minus 1 to the exponent 2. And then I can write it in this way. So we're going to find that term number 3 if you want to, or term number 4. But now, because I find the term 1 and term number 2, so we're going to create the value of r. The value of r is t2 divided by t1. And then our t2 in this case is x minus 1 squared. And then our t number 1 is x minus 1. So this means x minus 1, you cancel x minus 1 because J2 for the numerator. So this means the value of r is just x minus 1. So this is r. And then from here, we substitute r, because if p converges, and we about the convergent geometric series, and then the value of r, remember, is 0. So from here, or negative 1 is less than x minus 1, which is less than 1. And then x minus 1 is not equal to 0. So from here, I have to solve the value of x. The normal way is to solve the value of x on a linear inequality. So I have to change negative 1 ratio to the other side, and then ratio to the other side, and then you change as well. So this means negative 1 plus 1, which is less than x, and then 1 plus 1. Remember, I change as well. Therefore, 0 is less than x, and then x is less than 2. So this is our answer for number A. this is our answer for number A in a linear form. I mean to say in a linear inequality form. Now let's go to number B. Calculate the value of P when x is equals to 3. I mean to say x is equals to 2 over 3. So the value of P, remember this thing, this sigma, it's P, by feel P. So when we name our P, and then because at the time from term number 1 to infinity, and because this is a geometric nth term formula, so this thing is the sum to infinity. So here we already. So this means this is a sum to infinity. So actually, find our sum to infinity. So this means I'll find out the sum to infinity. A sum to infinity is equal to A divided by 1 minus R. And then I'll find the value of A and the value of R. But feel x is equal to 2 over 3. But T1 here A, and then our T1 is this one, which is x minus 1. And then what feel x is equal to 2 over 3. So this means after 2 over 3 minus 1. And then 2 over 3 minus 1, it's negative 1 over 3. So this is our A. And then let's find R. R is T2 divided by T1. So this is R. Our R is x minus 1. So our total are the same thing. I substitute the value of x, which is 2 over 3. So this is x minus 1, and even this one is x minus 1. So this means if I substitute the value of 2 over 3, we'll get the same thing. So R is equals to x minus 1, and then the value of x is 2 over 3. So 2 over 3 minus 1 will create the same thing, which is negative 1 over 3. And then from here, I substitute. So our A, it's negative 1 over 3. And then this is 1 minus negative 1 over 3. And then the answer is negative 1 over 4. So press the calculator. So there's no need to simplify your answer. So this is our answer for number B, a sum to infinity. And then I hope everything is clear. Even this question was kind of tricky, but not that tricky. So anyway, that's it for this tutorial.